Hello everyone, welcome to my video lecture on systems of particles which includes collision, session number 21. Collisions. I will define collision with an example, elastic and inelastic collisions with examples to show that when an incident particle collides obliquely with a target particle of mass at rest, both the particles move perpendicular to each other after collision. Perfectly inelastic collision and derivation of expression for Q value will be studied. Learning objectives. To make the students understand concept of collision, classification of collisions, various expressions for perfectly elastic collisions in terms of scattering angles, derivation of expression for Q value. Learning outcomes. Students are able to define collision, classify collisions, show that when an incident particle collides obliquely with a target particle of equal mass at rest, both the particles move perpendicular to each other after collision. Derive expression for Q value. Prerequisites. Students must have the concept of collision, concept of kinetic energy, law of conservation of linear momentum, resolution of momentum vector, expression for kinetic energy. Collisions. Collision is an interaction between particles which occurs in a small interval of time. There are two types of collisions: elastic collision, inelastic collision. Elastic collision. Collision in which both momentum and kinetic energy are conserved is called elastic collision. Example: collision between atomic, subatomic, nuclear and fundamental particles. Inelastic collision. Collision in which only momentum is conserved but kinetic energy is not conserved is called inelastic collision. Example: collision of two balls striking a bullet into wood. Elastic collision in two dimensions, oblique method. Consider an elastic collision between two particles of masses m1 and m2. This is particle 1, this is particle 2. v1 is velocity of this particle, 0 is velocity of this particle. v1 0 1, so this is u1. u1 is u1 is initial velocity of this particle, 0 is initial velocities. v1 and v2 are velocities after collisions. Alpha, angle of scattering, beta, angle of scattering of this particle. Law of conservation of momentum along x-axis separately. So this is x-axis. Now we have to take law of conservation of momentum along x-axis separately. Now initial momentum of particle 1 and particle 1. Initial momentum of particle 1 is mu1 because both particles have same mass m. Initial momentum of this particle is mu1, which is equal to final momentum of this particle. We are considering on x-axis. Now particle 1, mass is m, velocity is v1 and momentum is in this direction. Component of momentum in this direction is v1 cos alpha. Similarly, this is beta, which taken as negative angle. Now component of this momentum is mv2 cos of minus beta. This is positive, this is negative. So therefore momentum along x-axis is mu1 is equal to mv1 cos alpha plus mv2 cos of minus beta. Now simplify this, divide throughout by m, I will get u1 minus v1 cos alpha is equal to v2 cos beta. Now call it as equation number 1. Why? Because cos of minus beta is cos beta. Now I will apply law of conservation of momentum along y-axis. So the particle is moving in this direction. The momentum component along this direction is 0. So therefore initial momentum is 0 for both the particles, which is equal to momentum along y-axis of particle 1 is mv1 sin alpha. mv1 sin alpha. This is vertical component. This is horizontal component. mv1 sin alpha plus mv2 sin of minus beta. mv2 sin of minus beta. Sin of minus beta is minus sin beta. Substitute here and shift this to opposite sides. I will get V1 sin alpha is equal to V2 sin beta. Call it as equation number 2. In elastic collision, kinetic energy is conserved. Total initial kinetic energy of particle 1 is half m u1 square plus particle 2 is at rest. So therefore half m 0 square is equal to kinetic energy after collision is half m v1 square plus half m v2 square. This is for particle 1, this is for particle 2. This is for particle 1, this is for particle 2. So therefore multiply throughout by 2 and divide throughout by m. I will get u1 square is equal to v1 square plus v2 square. This implies that u1 square minus v1 square is equal to v2 square. Call it as equation number 3. Squaring and adding equations 1 and 2. I will get u1 square plus v1 square minus 2u1 v1 cos alpha is equal to v2 square. Call it as equation number 4 because sin square alpha plus cos square beta cos square alpha is equal to 1. Substituting equation 3 in equation number 4. So this one is substitute here. I will get u1 square plus v1 square minus 2u1 v1 cos alpha is equal to u1 square minus v1 square. Now, so I will rearrange the terms. 2 when this is this one cancels with each other. When this is shifted to opposite side, it will become plus v1 square. v1 square plus v1 square is 2v1 square is equal to 2u1 v1 cos alpha. This implies that v1 is equal to u1 cos alpha. Call it as equation number 5. Substituting equation 5 in equation 3, we get u1 square minus u1 square cos square alpha is equal to u1 square into 1 minus cos square alpha. This is equal to u1 is common factor, u1 square into 1 minus cos square alpha is sin square alpha, which is equal to u1 square as it is 1 minus cos square alpha is sin square alpha. So u1 square into sin square alpha is equal to v2 square. And then u1 sin alpha is equal to v2. Call it as equation number 6. Taking square root on both sides. When you take square roots, we will get u1 sin alpha is equal to v2. Dividing equation 2 by 1. I will get v2 sin beta by v2 cos beta is equal to v1 sin alpha by u1 minus v1 cos alpha. Here, divide left hand sides of equations separately left hand side. Divide equations right hand sides by right hand sides only. Now tan beta is equal to u1 cos alpha sin alpha divided by u1 minus u1 cos square alpha is equal to u1 cos alpha into sin alpha divided by u1 into 1 minus cos square alpha. 1 minus cos square alpha is sin square alpha. Substitute here. u1 cancels with each other. Next cos alpha sin alpha. So sin alpha, this square cancels with each other. We get cos alpha by sin alpha, which is cot alpha. This can be written as tan of pi by 2 minus alpha. Now this tan when take inverse on both sides, I will get beta is equal to pi by 2 minus alpha. This implies that alpha plus beta is equal to pi by 2. When an incident particle collides obliquely with a target particle of equal mass at rest, both the particles move perpendicular to each other after collision. In elastic collision, oblique method, I will consider inelastic collision of two particles of mass m1 and mass m2 moving with velocities u1 and v2. Their final velocities will become common velocity. m1 particle moving with velocity u1 and m2 particle moving with velocity v2. This is u1, this is u2. After collision, two particles stick together and move with common final velocity v. This is common velocity. Masses are added together, it will become single ball. By the law of conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 plus m2 v. Now we can write v is equal to m1 u1 plus m2 u2 divided by m1 plus m2. Call it as equation number 1. There are two types of inelastic scattering: endoergic scattering, exoergic scattering. In endoergic scattering, scattering in which the kinetic energy before collision is more than the kinetic energy after collision. Exoergic scattering, scattering in which the kinetic energy after collision is more than the kinetic energy before collision. So therefore Q less than 0, here Q greater than 0. Q value. The difference in the kinetic energy is called Q value. The change in kinetic energy is delta EK is equal to Q value, which is equal to total initial kinetic energy minus total final kinetic energy. half m1 u1 square per particle 1 plus half m2 u2 square per particle 2 minus half into m1 plus m2 v square. This is for single clinged ball, sticked ball. Now let us see question number 2. Q is equal to half m1 u1 square plus half m2 u2 square minus half, here substituting for v2, m1 plus m2 into m1 u1 plus m2 u2 whole square divided by m1 plus m2. This one cancels with each other. Finally, I am left with Q is equal to half into m1 u1 square plus m2 u2 square into m1 plus m2 minus this term. Use a plus b whole square form, which is a square plus b square plus 2ab. So this is this term m1 u1 whole square, m1 square u1 square plus m2 square u2 square plus 2 into m1 u1 m2 e2 divided by m1 m2. Now cancel the terms which cancel out. Finally, I will get Q is equal to half into m1 m2 divided by m1 plus m2 into u1 minus u2 whole square. Now I will call this as u mu. m1 m2 divided by m1 plus m2 is taken as mu. Now I can write Q is equal to half mu u square. Summary: elastic collision in 2 dimensions oblique method is studied when an incident particle collides obliquely with a target particle of equal mass at rest. Both the particles move perpendicular to each other after collision. In elastic or oblique method is studied. Derived expression for Q value. Thank you.